సబ్స్క్రైబ్ చేయండి అండ్ ఫర్ మోర్ అప్డేట్స్ బెల్ ఐకాన్ క్లిక్ చేయడం మర్చిపోకండి.
Now we are going to discuss voltage regulator. Voltage regulator means which device regulates the voltage. Which device regulates the voltage? Almost all electronic circuits require a direct supply voltage. Direct supply voltage. Almost all electronic circuits require a direct supply voltage. This DC voltage, direct current, this DC voltage is obtained from AC voltage. Generally, the current is in the form of AC, alternating current. That alternating current is converted into DC. That DC, almost all electronic circuits require that direct supply voltage. So the DC voltage is obtained from AC. So this DC voltage is produced from AC. Okay, first of all, what is the process of converting AC to DC? So AC supply transformation, first of all, what is rectification? This is the AC voltage. AC voltage is rectification. Rectification. So this AC voltage is converted into DC. Pulsating DC. So this is the rectification. And after rectification, this DC voltage, this DC voltage combination of pulsating, fluctuations, and AC components and refills. That AC component is filtering, then pure DC. First is the AC transformation and rectification and filtering. AC is converted into pure DC. First of all, AC is transformation and rectification and filtering, then we get finally pure DC. Okay, the resultant pure DC is not stable. Okay, the resultant pure DC after filtering, the resultant DC is not pure. The resultant pure DC is not stable. So the voltage regulator. So the voltage regulator circuits are employed to get the voltage more constant, stability. So the voltage regulator is used for stability of voltage. That means DC voltage is constant after the using voltage regulator. So and also then finally then we get pure DC and stable DC and constant DC. Totally reduce refills. So AC, first of all, transformation and rectification and filtering, then finally we get pure DC. This pure DC is not stable, is not constant, so we have to use voltage regulator. After you use voltage regulator, the pure DC is the stable and constant and reduce the refills. So in basic regulator circuit, we used the Zener diode as a voltage regulator. Generally, voltage regulators are available in three types. First one is the transistor series voltage regulator. Second one is the transistor shunt voltage regulator. IC voltage regulators 78 series and 79 series. Okay. Generally, IC voltage regulators are two types, 78 series and 79 series. 78 series is in positive voltage regulator, fixed voltage regulator, that is the positive voltage regulator, and 79 series is the fixed voltage regulator, that is the fixed negative voltage regulator. Okay. And also another voltage regulator is the variable voltage regulator, that is the LM317. Voltage regulator is the 317. Okay. This variable voltage regulator is the adjustable voltage regulator. Fixed voltage regulation is the voltage is the here fixed. So in our session, we have to learn the IC voltage regulators 78 series and 79 series and variable voltage regulator. IC voltage regulators 78 series and 79 series. For most applications, the better choice for a voltage regulator is 3-terminal IC regulator. 3-terminal IC regulator. So for most applications means most devices, the better choice for a voltage regulator, is 3-terminal IC regulator. 3-terminal IC regulator. 3-terminal means suppose for example, this is the ground to ground 3, this is the input. One is the input and another is the output and next is the grounded. One is the grounded, that is the earthed. Input, output, earth, grounded. This is the 3-pin regulator. 3-terminal IC regulator. 3-terminal IC regulator. It can produce a 3-terminal IC regulator. 3-terminal IC voltage regulator produced a fixed DC output voltage. Fixed DC output voltage from variable DC. Suppose in the previous session we discussed this is the AC rectification. After rectification, pulsating DC and filter, then pure DC. This is the pure DC. This is the rectified DC. This is the pure DC after filtering. This is the rectified DC after rectification. This is the AC. This is the pure DC. So by using of IC voltage regulator, 3-terminal IC voltage regulator, by using of 3-terminal IC voltage regulator, produce fixed DC voltage from variable DC. This is the variable DC. From this fixed DC voltage produced from this. This is the produced from rectification DC. This is the produced from AC. Okay. Then totally input of the voltage regulator is the filtered output DC. Input of the voltage is the filtered output DC. So this IC regulator is used in circuit to get a low voltage to steady voltage DC. Stable DC. For example, we use 723 IC regulator ranging output voltage from 2 volts to 37. 2 volts to 37. So this IC regulator, we used this IC regulator. So this output voltage from 2 volts to 37. 2 volts to 37. So this maximum supply voltage is 40 volts. This maximum supply voltage is 40 volts. This is the IC voltage regulators. These IC voltage regulators are two types. One is the fixed voltage regulator, positive. Okay, the regulators provide a constant positive output voltage. The regulator, already we discussed it, regulators provide a constant output voltage. Regulators provide a constant output voltage. So DC is the constant. So fixed voltage regulator, positive fixed voltage regulator provides a positive output DC. So in this session, in this case, the popular example is the 78 series XX. This is the 78 series. 7805 IC voltage regulator provides a constant voltage is the plus 5 volts output. If input range is 7.5 volts to 20 volts. So if input voltage 7.5 volts to 20 volts, then we get the constant DC voltage is positive 5. So less than 7.5, more than 20 volts, that regulation is not proper. Means less than 7.5, more than 20 is not proper. Which case is the proper? The input voltage lies between 7.5 volts to 20. 7.5 volts to 20. So the input voltage between 7.5 to 20 is the produce constant positive volts is the 5. But less than 7.5 volts, more than 20 volts, it's not proper regulation. So this type of regulators are known as fixed positive voltage regulator. This is the circuit of 78 series. So this is the fixed positive voltage regulator. Okay, fixed positive regulator is the best example is the 7805. In this case, plus 5 volts is the constant DC. But here condition is the input voltage is lies between 7.5 volts to 20 volts. Less than 7.5 volts, more than 20 volts is not proper. So the must condition is the 7.5 to 20 input voltage, then we get 5 volts DC voltage is the constant. Okay, this is the 7805. So this is the 78 series. The best examples in the 78 series is the 7805, 7806, and 7809, 7815. These are all best examples of 78 series. These are all fixed positive voltage regulators. Okay, in this 78 series, fixed positive voltage regulators. These are all fixed positive voltage regulators. Here, this IC denotes this XX. This term denotes the regulated DC. Regulated DC. This term denotes the regulated DC output voltage. Okay. So 78XX, 78 series IC, in the term XX is denoted regulated DC output voltage. So totally this is the fixed positive voltage regulator. In fixed positive voltage regulator, the input voltage is connected to input capacitor. This is the input terminal. This is the output terminal. This is the output capacitor is connected. This is the grounded. Totally this is the 78 series fixed positive voltage regulator. The IC 79 series is called as fixed negative voltage regulator. So these regulators provide a constant negative output voltage. Fixed negative voltage regulator provide a constant negative output voltage. In fixed positive voltage regulator, constant positive output voltage. So in this fixed negative voltage regulator provides a constant negative output voltage. So the best example, the popular example is here 7905. This is the 79 series. Here constant negative voltage is the minus 5 volts. So this minus 5 volts produced from input voltage is the minus 7.5 volts to minus 20 volts. This is the condition. So if input voltage ranges from 7.5 volts to minus 20 volts, then we get the minus 5 volts constant output voltage. But greater than the minus 7.5 volts and less than the minus 20 volts, if input voltage is greater than the minus 7.5, less than the minus 20, then there is no produce the constant voltage. If minus 5 volts constant voltage produced from, the voltage lies between minus 7.5 to minus 20. Above minus 7.5, below minus 20, there is no proper regulation. So these regulators is called as a fixed negative voltage regulator. In 79 series, this term indicates the regulated DC output voltage. Okay, so 79 series regulators are not preferable in all applications. Because this is the negative. Some applications are used but not preferable in all applications. But this IC 79 series voltage, low cost and easy to use. use. Okay, same as the circuit is the same circuit. This is the input, negative input capacitor grounded. This is the output. Series is the 79 series. This is the grounded. So this is the fixed negative voltage regulator. So in fixed positive voltage regulator, in fixed negative voltage regulator, the input capacitor Ci is used to prevent unwanted oscillations, and output capacitor C0 acts as a line filter. So it improve the DC voltage purification. Next classification is the variable voltage regulator. This is also an adjustable voltage regulator. It is also an adjustable voltage regulator. That we know that fixed positive voltage regulator, fixed negative voltage regulator. IC, integrated circuits. Fixed positive voltage regulator, fixed negative voltage regulators. But in this regulator, an adjustable voltage regulator, variable voltage regulator, because then output voltage produced from adjustable regulation. An adjustable voltage regulator produces a DC output voltage which can be adjusted with required voltage. Adjusted required voltage, any other value of certain voltage range. Then this is the output, this is the input, this is the adjustable. So we require some 5 volts. So the input voltage is 330 volts. We require the 5 volts. Then here this pin is the adjusted to 5 volts. This is the variable voltage regulator. An adjustable voltage regulator produces a DC output voltage which can be adjusted to any other value. Hence, adjustable voltage regulator is also as a variable voltage regulator. The DC output voltage, this is the DC output voltage value of a adjustable voltage regulator can be either positive or negative. So here the best example of variable voltage regulator and adjustable voltage regulator is the LM317 series. So this is also called as 3-pin regulator, 3-pin voltage regulator. So LM317 voltage regulator IC can be used for producing desired positive fixed DC voltage value of the adjustable from IC LM317. So then we require 10 volts. This IC is adjusted to output voltage 10 volts. We required 12 volts. The IC LM317 is adjusted to the output voltage is the 12 volts. Then we required the 5 volts. This IC adjustable to 5 volts. So this an adjustable voltage regulator IC has 3 pins. The first pin is used for adjusting the output voltage. This is the first pin. The first pin is used for adjusting the output voltage. The second pin is used for the collecting the output. This is the second pin. This is the second pin. This is the second pin. So the second pin is used for collecting the output DC, and third pin is for connecting in the input. This is the third pin. So third pin is connected into input voltage, input. Second pin is connected to collecting the output DC. Third pin is the first pin is the adjustable. Third pin is the adjustable to the output voltage. First is the adjustable, second is the output, third is the input. Third is the input, second is the output, first is the adjustable to output voltage. So the adjustable pin terminal, the adjustable pin means terminal, is provided with a variable resistor which lets the output to vary between wide range. This is the circuit of variable voltage regulator and 3-pin regulator. 3-pin means three terminals. First terminal is connected to output to adjustable resistor. Second pin is connected to collecting the output DC voltage. Third pin is connected to connecting the input voltage.